Welcome back. Let's take a look at this problem again. We've already discovered from the previous video that alpha was 129.21 degrees and theta is 13.88654. Lots more digits than I need, but I'll spit them all out there anyway. Okay, I want to solve this problem. First off, using law of cosines, because it's pretty quick and easy. So I know the angle between AD and DP, and I know the length of AD and DP. So the law of cosine says that RAP squared, I'm going to go ahead and put the magnitude up there, equals RAD squared plus RDP squared minus 2 RAD RDP cosine of alpha. Okay, so RAD is given at 50 millimeters. Square that plus 125 millimeters. Square that minus 2 times 50 millimeters times 125 millimeters times the cosine of 129.21. Okay, and pull that minus sign down here. And if I solve all this out, keep in mind the cosine will be negative, so this will be a plus. And then I add all that together, and then I'm going to take the square root. So RAP will be 161.2188. Yep, 2188. Notice that that's not exactly the same numerical value that I found in the previous video, but and significant digits actually have caught me in the act here, because when I round this off, I'm going to get 161 millimeters, right? 161 millimeters. And last video, I got 162 when I rounded it off. Okay, so a little bit of a variation in there. So here I get 161 millimeters. Okay, so you want to be careful with your significant digits because it matters. It's going to make a difference. Part of that is that I assume 36.9 there's more digits in there than I've got spit out, because I said, hey, that's a 3, 4, 5 triangle angle. So I should probably have a lot more digits in here. But there's some round off error in there, so we got to be careful of that, because I've got two different answers because of the way things rounded off. Okay? All right, not going to worry about it here, but something to keep in mind. The other way I want to solve this problem is using components. So I've got RAD, and that's got a length of 50 millimeters at an angle of 36.9 degrees. So there it is in polar form. Right, I've written this out in polar form. And so that's going to be 50 millimeters cosine of 36.9, but this is a 3, 4, 5 triangle, so that's going to be 4 over 5, right? So 50 millimeters times 4/5. That's in the I hat direction, plus 50 millimeters times 3/5 in the J hat direction. All right, and that's going to simply be 40 millimeters I plus 30 millimeters J. Okay, so there's RAD written out in vector Cartesian format here. Here it is polar, and this is in Cartesian. And I'll show you later on, your calculator will do all this for you. Makes life a whole lot simpler. Okay, and then RDP, that's 125 millimeters. Now the angle is the interesting thing here, right? So I know what theta is. Okay, theta is 13.88654. But if I draw a horizontal line here, horizontal line means that this and this are parallel. Alternate interior angles are here and here, so this is also theta, right? Alternate interior angle says that's also theta. So RDP points down below the positive x-axis, so minus 13.88. I'm going to put out all that, 654 degrees. Okay, so minus, because it's pointing below the positive x-axis, so that's negative. All right, so this is going to be 125 millimeters cosine of theta. And actually, I'm going to say minus theta, I hat, because theta is a magnitude, and we know it's pointing down, so it's negative, plus 125 millimeters sine of minus theta, j hat. Okay, so because theta is measured with respect to the positive x-axis, the x-axis will be, the x component, will be cosine, and the y component will be sine. All right, and if I work all that out, I get 121.3466 I hat, and that's millimeters, minus 30 j hat, and that's millimeters. And that makes sense because the negative 30 and the positive 30, when I add these two vectors together, the sum of those two vectors has no y component. That was one of the things that I kind of defined here. So there's no y component. So that works out. Positive 30, negative 30 cancels out to 0. There's no j hat. And then 40 plus 121 equals 161.3466. Yet another different value. But when I round it off, I'll get 161. Okay? I may have had a slight error in this 162. I don't know. I'd have to go back and look. But you get the idea. So there's my value for, again, I've got to say 161 when I round it off to 3 significant digits, which is what I've got in these values in here. There's 3 digits. Okay, so 161. All right. If you have any questions on that, please leave them in the comments below. Thank you.